Oh, so this is where we left off, right? We did one repetition of the scenario, okay? And then we stopped there. So we're going to do that, except we need to do that 19 more times, okay? Because we need 20 trials. So the first repetition, right, we had, because our rules, right, we have two rules. One rule is, when do we get a positive case? We said 0 to 14 on the random numbers chart. And then we said 15 to 99 is a negative case because there's a 15% chance of catching the disease if you come in contact with someone. And then our second rule was, okay, so when do we stop one trial and go on to the next? Well, there was 4 kids in the family, so we said 4 kids. After the 4th kid, we'll stop and do another trial. We'll stop in with that trial. Okay? We did one trial, 4 kids, all negatives, all numbers that fell into the negatives, right? So in that trial, we had 0 children get strep throat. So now what we got to do is, before we can do our other 19, we have to create a scoreboard. Now in sports, what does a scoreboard do? Exactly, tracks points, right? Who's winning and who's losing, right? Because if the scoreboard wasn't up there, you wouldn't know unless you were keeping track on your own, and no one does that. Who's excuse me, who's winning and who's losing? Keeps tracks of the points, right? Where we're at in the game, right? So what is our scoreboard going to look like? What should our scoreboard look like? Because remember, after this, we're going to have to answer these questions down here. We're going to have to fill in these blanks here. Those are the questions we need to answer. So what should our scoreboard look like? What should our scoreboard have? What should our scoreboard have? What are things that it should have? What are things it should tell us? How many children that got strep throat? Altogether, each time, which one do we need? Definitely, we need to know how many kids got strep throat for sure. But do we need to know each time this many kids, or do we just need to know overall 50 kids got strep throat? Each time. It's looking like each time. If you look at the questions right here, each time, right? So we need to know what happened each time. Okay. So that's going to lead us to, how many categories of things can happen? How many categories of things can happen every time I do a trial? How many different things I should say, how many different things can happen when I do one trial? What are the 5 things, Josh? Yep, that's it. Right? That's all that could happen. I can't have 6 kids get it, right? I can't have 5 kids get it. I can't have 10 kids get it because there's only 4 kids. So I need to have a column for every single one of those situations. So 0, 1, 2, 3, 4. Okay. So what are these? What are 0, 1, 2, 3, and 4? It's the number of kids. No, let me do this. Number of kids sick during each trial. The number of kids sick during each trial. I can have 1 kid get sick. I can have 2 kids get sick. I can have 3 kids get sick. I can have 4 kids get sick. I can have no kids get sick. That's all that can happen. We call those random variables. Those are the only things that can happen. Okay? We already did one trial. What happened on that one trial? No kids got sick. So what are we going to put? Yep, we're going to put a little tally mark on 0. Put a little tally mark in that column because we already had one like that. Okay? So when are we going to know we're done? What is our scoreboard going to have when we're done? 20 tallies. Yeah, when it has 20 tallies, we know we are done. And I'll have enough information to go answer the next 1, 2, 3, 4, 5, 6 questions. Okay. All right. So since we did it yesterday, we'll do one together and then I'll leave you to do the other 18. Okay. So second trial. Second trial needs four kids, right? What number do we leave off on? 47, right? 47. So go find 47 in the first, it should be in the first row. 47. Right here. Now let me use a different color. Right here. 47's right there. Okay. So now I need the next four. The next four. So the next student, or the next is going to be, not student, the next child is going to be 27. Then the next one after that will be 88. Then 79. Then 59. So how many kids got sick that time? 0 again, right? Because our rules state, we set out rules that said 0 to 14, 0 to 14 are a positive case. Negative case was 15 to 99, and it looks like all of those were there. So what do we get? 27, 88, 79. No, no. When you get going, you don't have to. You just have to keep track of where you're at so that you don't lose your place. But you don't have to do this every single time. So no kids got sick, so we put another tally mark in the 0 category. All right. Okay, so I'll give you guys some time. You guys are going to do that now until I get 18 more tally marks, 20 total. Okay. Okay, so what'd you guys get? How many zeros did you guys get? Good. So 12 zeros. How many ones? 6. 18 so far. So we have 2 more that are out there. What about 2s? 1, 2, 3, and no 4s. Okay. So now we can answer our questions. We have, like I said, we have some questions down here. So based on our 20 trials, what percent chance is it that 0 kids? How are we going to figure that out? Yeah, what are we going to do with 20? Mm-hmm. So for this one, it's what divided by what? 12 divided by 20. Convert it to a percent. What do you get? I think that's 60%. The next one is 30%. And then 5 and 5 and 0. Okay. So sometimes what they'll do is they'll give you a set of questions like that. Sometimes what they do, your conclusion is going to be answering the questions. The next one that you guys are going to do on your own in a second, they just pose one question. So everything's going to be based off of answering that one question. Okay? So let's look at the next one you guys are going to do. You guys are going to do this one on your own. Okay, a soft drink company printed messages inside its 20-ounce bottles as part of a promotion. Coke used to do this, Pepsi used to do this all the time, where they'd have bottle caps, you'd open them up, and you'd read inside and it says you're a winner or you try again. And if you won, it tell you what prize you get. You know, sometimes you get a free drink, sometimes you'd win money, sometimes you'd win whatever. So they used to do that. I don't know if they still do, but that's what they used to do. Some of the caps said please try again, while others said you're a winner. The company claims that 1 in 6 bottles have winning caps. That's their claim, right? 1 in 6 bottles are winners. So if I go to the store and buy 6, if I go to Save Mart right now and buy 6, does that mean I'm going to win once? Why not? You're right. Why not? We talked about this yesterday. Exactly. Probability only applies to big, 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 big. If I went to go buy 6 million bottles, about 1 million would be winners, right? Doesn't win if you're short sighted, doesn't win, right? It's very unpredictable if it's short sighted. I go walk to a casino right now and place a bet, very unpredictable on what could happen, right? But if I sit there at the casino and play nothing but that same game every day for a week, in the end, I'm going to lose, right? That's what we talked about yesterday. Okay, so 7 friends each buy a bottle at Save Mart of that drink. The clerk is surprised when 3 of them are winners. Is this group just lucky, or is the company's claim inaccurate? That's the question right there. Are they lucky, or are they inaccurate? Okay, so we got to answer this question, we're going to have to conduct a simulation with 20 trials to answer the questions. Okay? First thing we're going to have to do, assign digits. Assign digits. What's the probability here? Like the probability here was 15.15, 15%. We had to create 15%, right? What's the probability for the one in front of you? About 16%, 1 in 6, right? 1 in 6. How do I create that? There's a couple different ways. How do I create it? What's the easiest way to create that probability? Mm-hmm. That would work. Problem there is you're rounding a little bit, right? 1 divided by 6 is like, yeah, it's between 16 and 17, right? So that way would work. Nothing wrong with that way. But what's one way I could do that would be even more accurate with percentage, with probabilities? Does anyone have any ideas? Yes, you could do that. Mhm. That's one way to do it. Yeah, that would be for sure, right? 1 out of 6, 1 out of 6. Thinking along those lines, what's another way to do it? Just like what Armin said, but a different method. That would be a lot really easy. What would be an easier method than that? Think of 1 and 6, right? There you go. That's what I was thinking. Just roll a die. Roll a die. It's 1 out of 6, right? It's got 6 sides, 1 out of 6, right? That's the same thing as Armin said. If you have a calculator, I would say do that one. If you don't have a calculator, I would say roll a die. Um, or if you all have Chromebooks at home. If you go to, watch, I'll show you. If you go and you Google roll a die, literally roll a die, Google roll a die, it gives you many, many, many different types of die. 4-sided die, 6-sided die, 8-sided die, 10-sided, 12, 20, and then you just hit roll, and it's the same probabilities. It's an algorithm that they've created that is random, just like rolling a die, right? They also, if you want to do flip a coin, flip a coin, tails, flip again, heads, same thing like that. Okay, so all of those will work. All of those will work. It's just, could I? How about this? How about really go really lo-fi? Could I get a piece of paper, cut it up into 6 pieces, label each piece 1, 2, 3, 4, 5, and 6, put them in a hat, put them in a paper bag, and pick one like that? Is that a method too? That would work? Yep, that would work too. Okay, so there's different types of methods that work. This one doesn't say you have to use a random number chart. This one doesn't say you have to use calculator. This one doesn't say you have to use what. It kind of says what you want to do. So any way you can create that. Okay, any way you can create that. That's how we're going to create that. Just explain it. So which one do I use? That's what you're going to explain assigning digits. How are you determining your randomness? When this happens, this will happen. I'm going to use this. When this happens, I know it's going to be a winner. When this happens, I know it's going to be a loser. Okay? That's what you have to explain. Stopping rule. So when am I going to go on from one trial to the next trial? There you go. Yeah. You got to do 7 in this case, right? Yeah, Josh, why 7? Exactly. We're trying to recreate what happened in the store. 7 friends went, 3 of them won. What are the chances of that happening? That's what you're trying to recreate with this problem. Okay? So the stopping rule will be after you get the 7th friend. After the 7th friend we figure out what happened to that 7th friend. Okay? Then you're going to do 1 repetition. It's not going to have 4 like we did here. It's going to have 7. What's going to happen for each? What's going to be the outcomes? What are the possible outcomes for each of the 7 people? Winner or loser. Winner or loser. Winner or loser. Okay? And then at the end, you have to create some sort of scoreboard that's going to help me answer the question of, were those people lucky or are they lying? What's going on here? Okay? So you're going to create a scoreboard based off of that. All right? And then once you're done with all of that, you can answer the question. Okay? Okay, so I'm going to give you guys about 10, 15 minutes to do that. Go for it. Whatever you want to choose, whatever your method of choosing is, whatever your method of, if you want to use the random number chart, you can just use the one that we used earlier. You can use the same one if you want to use the random number chart, if that's your method. If you want to use a calculator, you can use a calculator. Just explain what you did as part of your assigning digits. Okay. So this was my method. Now we talked about it. There's lots of different ways to do it. I chose to roll a die. I just used Google and did 20 trials of 7 people times. So my assigning digits was, if I rolled a 1, that meant I won. I won a prize. If I rolled a 2, 3, 4, 5, or 6, I didn't win a prize. That person didn't win a prize. My stopping rule was after the 7th friend. Okay? Because if a 1 out of 6, that's a 1 out of 6. That's what we're looking for, right? So I did 1 repetition. So on the first got a 1. The first one I rolled a 1. So that first friend would win. The next the second, third, fourth, and fifth person rolled something other than a 1. The sixth person rolled a 1 again, so that person would win, and the seventh person got a 4, so 2 on this case, and then my scoreboard was how many people won? How many people won? Okay, number of people who won each trial.
So, like, I didn't get any for 3 at all, but like I got some for like 5.
Mm-hmm.
How would I word that for my conclusion?
Oh, in your conclusion, we'll talk about that right now. Yeah. So it's clear from my board how many times 3 people won. Just once, 1 out of 20, 5%. All right. No more. In mine, nobody won more than 3. Okay. Yours is going to be different because you weren't looking at my number. Unless we were doing it together using the same algorithm at the same time, it's not going to be the same. If it was the same, that would be the chances of that happening. How many times did I roll? 7 times 140 rolls being the same would be crazy. Okay. So that's my scoreboard. Okay. So you could see that 2, most of the time I had 11, 55% of the time. 2 people won in the group. 2 people won in the group, right? 4 out of 20. So what is that? 20% of the time, nobody won or 1 person won. And then 5% of the time, 3 people won. Okay. So the conclusion. So based off of all that, how do I conclude it? Well, you got to answer the question, right? You got to answer the question? What was the question? Is this group just lucky, or is the company's claim inaccurate? Based off my 20 trials, 5% of the times 3 friends won a prize. Now, if you have, I would say more than 3, right? I would say if you didn't have anybody for 3, how many did you have that had more than 3? So I would change it to say 5% of the time, 3 or more won a prize. Okay.
So what if nobody ever scored 3? So based on your trial, 0% of the time?
0 per. You should say 0. You say 0% of the time, 3 or more friends won a prize. That's even more definitive. So if 5% is low, 0% is even lower. There's nothing you can get lower than 0%. It didn't happen. So is this group lucky, or is the company's claims inaccurate? It's very lucky. Very lucky. If the number was higher, if the number was significantly higher, then we would say they're just wrong, right? The company's just wrong, that it's not 1 in 6, it's actually more. Well, no, we're showing that it's actually only 5% of the time it's happening. So yeah, they're just lucky group, which can happen, right? If one group of people walk in unpredictable, right? But if they walk in every day, for a month, for 6 months, for a year, and do the same thing, overall, their luck would even out. I have another question. So when I was doing the rolling the die, have you ever heard of a person being on a hot streak? I keep getting that number. Oh man, I keep getting that number. Is there something to that? Is there something to a hot streak? Does their probability change? Because let's say I roll a 1, like I got like 3 ones in a row. 1, 1, 1. Hmm? Is there anything to that? Why not? Is there such thing as a hot streak, I should say?
It's a 1 in 6 chance to get it. It's just 1.
It's just there's always a 1 in 6 chance, right? Even though it seems like exactly, it seems like you're rolling it right. Did you forget about the times when you didn't roll the 1 8 times in a row, right? People don't remember that. They just remember, oh, I keep getting that number, 7 or whatever their number is. I keep rolling that, I'm on a hot streak. No, it's still the same probability, right? It's just chance, right? It's just random chance that it's happening. Okay. So a lot of times people say, I'm on a hot streak. Yeah, that doesn't mean anything. The probabilities haven't changed. Okay. The probabilities have not changed. Alrighty. Okay, so we're not going to get too much into it, but let's look at least the big part of the next one, of the next, what we're going to get into next week. Excuse me. A couple of vocabulary. Sample space. Sample space. A sample space of a chance process is all possible outcomes, everything that could happen. So an example here would be if I roll 2 die, what can happen? That. There's nothing else that can happen if you roll 2 6-sided die. Right? I can get a 1 and a 1. I can get a 2 and a 1. I can get a 3 and a 1. I can get a 4 and a 1. I can get a 5 and a 1. I can get a 6 and a 1. I can get a 1 and a 2, a 2 and a 2, a 3 and a 2, so on and so forth. How many different outcomes are there? 6 times 6, which is 36. There are 36 different outcomes in this sample space. It means anything that could happen. So it could be as much as 36. It could be as little as two things that can happen, right? When you take a test, what is the sample space of outcomes that could happen? 1 through 100%. Or if there's extra credit over 100%, what about in terms of grades? How many things can happen in terms of letter grades? A, B, C, D, or F. 5, yeah. You're not going to get anything other than an A, B. If it's from a 90 or above, it's an A. If it's 80 to 89, it's a B. If it's 70 to 79, it's a C. 60 to 69 is a D. Anything below that's an F, right? There's nothing else you can get on a test, right? So though it could be a small sample space, what's the sample space of a coin? 2 things, right? What are those 2 things? Heads or tails, right? What's the sample space on 1 die? That's it, right? 1, 2, 3, 4, 5, or 6. 6 things that could happen. What's the sample space for 3 die? Which is? There you go. There you go. Use your calculator. 216, thank you. 216 different things that could happen, right? So sometimes they'll have you list everything that can happen. Sometimes they'll have you just say what is the sample space. Now, if it's 216 different things that can happen, they're not going to have you list all of them, right? Exactly, right? If I flip 2 coins, let's say I flip 2 coins. What's the sample space of flipping 2 coins? 4 things, right? What are those 4 things? This is what messes people up. They say, aren't the last 2 the same? So isn't it really 3 things that can happen? Aren't the last 2 the same? Isn't it 3? Yeah, and why does that matter? After the first flip, I don't know what's going to happen when I'm flipping a coin, right? After the first flip, those are totally different. Now, at the end, they ended up being the same, right? But while I was doing it, it wasn't the same. So that's why order matters, right? And if you're assigning something to it, then yeah, that too. Yeah, for sure. So don't get confused. Like people will see there's a 6 and a 1 here, and there's a 1 and a 6 there. Aren't those the same thing? They could be. They're if you're adding up digits, right? They could be the same thing. But isn't 3 and 4? Where's 3 and 4? Isn't 3 and 4 the same thing? Right? So it doesn't matter what you're doing, the outcome is different, right? Like you could have a person who has the same exact schedule as you, is just opposite, right? Whatever you do at first block, they do 7th block. Whatever you do second block, they do 6th block, and so on and so forth, right? At the end of the day, you all went to the same classes, but your outcomes are different, right? You only had 1 class in common. You only had 1 class at the same time, right? Everything else was different. right? So the outcome might be the same. You went to the same classes, you saw the same teachers, but in those classes you had different students, right? And you went at a different time. Okay. Probability model. Probability model is a table based on some chance process that consists of two parts: the sample space and the probability of each. So I'll do a quick one right here. Okay, so one of them is the sample space, flipping two coins. What are the possible things that could happen if I flip two coins? 4 things that could happen. We just said that, right? We listed them up here, right? So we can say number of tails. How many tails can I get when I flip 2 coins? I can get 2 tails, both tails, right? What else can happen? I can get 2 heads, which means I got 0 tails. And then what else? Looking at this picture here, what's the probability that I get no tails? 1/4, right? Yeah, let's use that as first decimal. What's the probability I get 2 tails? Same. So this is the probability of tails. What's the probability I get 1 tail? That right there, that table right there, is a probability model. It tells us exactly what the probabilities are. The probability you got 1 head, usually we put them in order. Since the probabilities are the same, I'm going to put them in order. Lowest to highest, right? Always numbers. They're not going to be, that's why I didn't put tails and heads, the words in here, because it's always numbers that we cover. Okay?
Even if it was heads, aren't the percentages the same?
Yep, they'd be the same, right? Okay? Last thing. An event. An event is anything that happens. Anything that happens. It's a subset of the sample space. Okay? So an event could be, what's the probability of me rolling a 1 and a 1? 1 out of 36, right? Probability of me rolling a sum of 6. 6 dots. When I roll, I get 6 dots. Which ones have 6 dots? So I have, let's see, 6, 6, 6. I missed one. Let's see. I'm over here now. 6, 6. That's it, right?
It should be an equal amount. 1, 2, 3, 4, 5. You're missing 1. Oh, you're missing the other 3, 3.
Oh, 3, 3. Where is that?
3, 3.
Oh, 3. Oh, that's it, right?
Only 1, 3, 3. Oh,
5 out of 36, right? That's an event, right? Me rolling 6 and counting 6 digits, 6 dots, right? That's an event. Okay, one thing that can happen. It could be, okay, so and then we'll pick up from there on. There's going to be the homework assignment. It won't be due till Tuesday, so it's not necessarily a